Hello everyone, welcome to course study on solid mechanics. Again we will discuss the numericals based on the flexural formula. The statement of the numerical is as follows. Maximum bending moment of simply supported beam is 10 kN meter. The cross section of the beam is as shown in figure. Find out the maximum bending stress in tension and compression. Now in this numerical, the cross section of the beam is given and the value of maximum bending moment is already given in the numerical. We did not require to calculate the value of maximum bending moment. It is already given in the numerical. It is 10 kN meter. We have to find out the value of maximum bending stress in tension and compression. Now from figure we can see that this is a rectangular section. This is a rectangular section of depth 120 mm and width equal to 60 mm. From this rectangular section, a square section is removed and the size of this square section is 20 mm by 20 mm. This is the square section which has been removed from the rectangular section. For such a section, we have to find out the value of maximum bending stress in tension and compression. Remember that again we are going to find out the value of stress induced into the beam by using the flexural formula. To find out the value of stress, again we will find out the value of I and the value of YC and YT. We are not going to find out the value of M because the value of M is already given in the numerical. It is 10 kN meter. Now from the diagram we have Y bar is equal to A1Y1 minus A2Y2 upon A1 minus A2. Remember that Y bar is nothing but it is the position of the neutral axis for the entire section. Now from the given section, from the given rectangular section we have removed this square section. Therefore the formula will become A1Y1 minus A2Y2. Remember that this minus sign for the removing of this square section. This minus sign we have used for the removing of this square section. Therefore we have the position of neutral axis as A1Y1 minus A2Y2 upon A1 minus A2. Therefore we have A1. Suppose that the entire rectangular section we will consider as a 1 and this square section which we have removed we will consider it as a second section. Therefore A1 will become 1200 into 60. This total depth is 1200 and this total width is 60. Therefore the area will become 1200 into 60 and that will be 72,000 mm square. This is the value of area for section 1. For the same section 1 we are going to find out the value of Y1. Now for the entire rectangular section we have depth equal to 120 mm. So 120 mm divided by 2 means half of it will give you the value of Y1, that is 60 mm. This is the value of A1 and Y1 for section 1. Now we will concentrate on section 2, that is a square section which has been removed from the rectangular section. Therefore we have A2 is equal to this 20 mm into this 20 mm. So area will become 400 mm square. And we have Y2 is equal to this 20 mm plus half of this 20 mm. So it will become 30 mm. On putting the value of A1Y1 and A2Y2 into equation of Y bar, I have position of neutral axis as 61.76 mm from the bottom face, because the bottom face we have considered it as a reference face, and with respect to that we have determined the value of A1 Y1 and A2 Y2. Therefore this is the value of YT. Why this is YT, why not YC? Because it is a simply supported beam which is subjected to which has a moment of 10 kilonewton meter. But as it is simply supported one, the layer which is below the neutral axis is in tension, whereas the layer which is above the neutral axis will be in compression. Therefore, from the bottom face, we have the value of Yt as 61.76 mm. Once you know the value of Yt, we can easily find out the value of Yc also, because Yc will become the total depth minus Yt. Therefore, we have total depth as 120 minus Yt as 61.76. Therefore, we have Yc is equal to 58.24 mm. Now, in this manner, we have find out the value of position of neutral axis for the given section. Now, we are going to find out the value of moment of inertia for the entire section. As we have removed the square section from the rectangular section, so we have final moment as I is equal to Ixx1 minus Ixx2. This minus sign, it is for the removing of a square section from the rectangular section. Again, we are going to apply the parallel axis theorem for the same. For the first section, this is first section, this is second section. For the first section, we have Ig1 is equal to 60 into 120 cube by 12, plus area will become 7200 and h1 square will become 61.76 minus 60 square. This is the value of Ixx1 minus Ixx2, means it is 20 into 20 cube divided by 12, plus area will become 4000 into 61.76 minus 30 bracket square. This is the value of Ixx2. So once you know the value of Ixx1 and Ixx2, and on subtraction we have the value of moment of inertia for the entire section. It is 8.60 into 10 raised to 6 mm raised to 4. Now we have find out the value of moment of inertia for entire section. The value of maximum bending moment, which is 10 kilonewton meter, is already given in the numerical, and we have find out the value of Yc and Yt. We have sigma c is equal to 67.72 megapascal or Newton per mm square, and Yt is equal to 71.81 megapascal. Oh, here it is, instead of sigma c it is sigma t. By mistake this happened. This is not sigma c, it is sigma t. So the value of sigma t is 71.81 megapascal. So as given in the numerical, we have to find out the value of maximum bending stress induced into the tension and compression. So we have sigma c and sigma t as this value and this value. Here it is, we have found out the both value of stresses in this particular numerical. In the next lecture, we will discuss the concept of shear stress. So we will stop here. Thank you.